Now octahedral complexes, they show something which is known as pi bonding. Like pi bonds. Octahedral complexes, they form the normal sigma bonds in which the ligand donates to the metal. The ligand donates its electrons to the vacant orbital of the metal. That is your normal sigma bond. But some octahedral complexes are also have been found to have another bond. Now this bond can either be metal donating to the ligand, or this bond can also be again ligand donating to the metal. The second bond is the pi bond. So this is the pi bond which is shown by octahedral complexes. Now there are some specific ligands, okay, which show a pi bond or which are capable of forming a pi bond. I know we have already done many types of ligands. We have done monodentate, we have done didentate, we have done bidentate. Didentate, bidentate are the same thing. Tridentate, tetradentate, pentadentate, hexadentate. But this is another type of classification of ligands. Ligands, that is sigma donor ligands, pi donor ligands and pi acceptor ligands. So pi donors and pi acceptors we are going to see in the next slides. Sigma donor ligands are those ligands which can only donate once, that is only this or a sigma bond is formed. Only one sigma bond is formed in which the ligand is donating to the metal atom. If there is only one and only bond, then those ligands are known as sigma donors. Now let us see what are the other type of ligands present. First we have our d pi p pi bonding. So the d pi p pi bonding, in it the pi electrons, they are donated from the p orbitals of the ligand to the vacant d orbitals of the metal. Like some ligands have a p orbital, right? Let's say T2G, and then the metal can have vacant d orbitals. Like when we talk about your ligands F negative, Cl negative, Br negative, I negative, H2O, OH negative. In all of this, what happens is, let's say these are the metals orbitals, okay, these are the metals orbitals and these are the ligands orbitals. Now between this and this, there will be a sigma bond formed, that is the ligand is donating to the empty orbital of the d, that is empty orbital of the d orbital of the metal. But these electrons which are present in the other orbitals of the ligands, they can also be donated to form a sideways overlap, forming a pi bond. What is happening? The ligand is donating to the metal to form a sigma bond, but the ligand is also donating to the metal to form a pi bond. In this case, the only thing that should be present is that the metal should be in high oxidation state. High oxidation state means that the metal should have less electrons. If the metal has less electrons, or if the metal has no electrons, then only you are going to, that is the ligand can put that many electrons into the metal's empty orbitals. If the metal's orbitals are already filled, that is if it has a low oxidation state, means it has electrons, right? And if it has low oxidation state, it has electrons, then it means that the ligand will not be able to donate the electrons into the empty orbitals of the metal, because metal is not going to have any empty orbitals. So the metals should be present in a high oxidation state, and the donation is going to happen from the p orbitals of the ligand to the empty d orbitals of the metal. So this is your first type of bonding, which is called the d pi p pi bonding. The second type of bonding is the d pi bonding. In this case, the pi electrons are donated from the d orbitals of the metal to the vacant d orbitals of the ligand. Like when we talk about R3p, R3as, R2s. In all of them, phosphorus as well as arsenic as well as sulfur, they have lone pairs of electrons, so they can be donated to the metal. Fine. All of these are ligands, okay. So all of these, they have lone pairs and can be donated to the metal to form a sigma bond. But all of them also have vacant d orbitals. So the metal can donate the electrons back to the vacant d orbital of the ligand and form a pi bond. First of all, a sigma bond is formed here. This is the ligand and this is the metal. And the pi bond, it is formed from here. This is the sigma bond. So this is the pi bond and this is the sigma bond. So this is the pi bonding, in which metal is donating to the ligand is also donating to the metal. In this, the criteria is that the metal should be present in low oxidation state. If the metal is present in low oxidation state, means it is going to have electrons, and if it has electrons, then only it is going to donate to the vacant d orbitals of the ligand. So, metal should have low oxidation state in case of d pi bonding. This is called d pi because the donation is happening from d orbital to the d orbital. In the last one, the donation was happening from p orbital to the d orbital, so it was p pi d pi. This is d pi. Now, there is another type of pi bonding, which is d pi to pi star. In this, the pi electrons are donated from the d orbitals of the metal to the vacant pi star orbitals of the ligand. This type of bonding is shown by CO, Cn, NO, bipyridine, orthophenanthroline. All of these ligands are going to show d pi star pi bonding, because all of these ligands in that the pi star orbital, that is the pi antibonding orbital, is going to be empty. So, the metal can take its electrons which is present in the d orbitals and donate those electrons into the pi star orbitals of the ligand. So, these were the three types of pi bonding which can be present in your metal complexes, and I told you which are the ligands which are going to show these type of bondings.